Welcome back. Today I'm going to find out if I can import and run a modern program from Fusion 360 in this ancient CNC machine built in 1989. Will it work or will I fail miserably? Let's find out. Nice and smooth too. Give it a love tap. So this is a 1989 Matsura CNC machining center. If you guys missed the video where I did Will It Run on this, go back and check it out. Great video. The plan is to drip feed a longer modern code from Fusion 360 into this machine and see if it can handle it and see how it runs on modern code. So how I plan on doing that is this Titan DNC box right here. I have a couple of these for a couple of machines that I ran, and they're awesome. I'll leave a link in the description below where you can purchase these if you want to find one of these. They're like $300, I think, with free shipping on Amazon. So they're just magnetized wherever you want to put them, and then you connect your RS-232 port, and then you can import programs or just save programs inside of here and feed them in as you want. You can also take the parameters from the machine and back them up on this through a stick. So this is a great addition to any older machine. So it's going to be a little bit of work. I have to match up all the parameters on the DNC box to the parameters in the remote so that they can communicate together. And then this controller right here actually has what's called tape feed. And usually any controller that has that tape feed option means that if it's a huge program that the controller can't handle, it'll tape feed from outside. It'll take in just what it needs and what it can handle, buffer it, and it'll keep running non-stop if you have a DNC box like this. So let's get the machine powered on, homed out, maybe turn on the spindle, warm it up a little bit. And I actually have the manual for this. This is I found it online and downloaded it. This is a MX3, a Yaznak MS3 controller. And what we have to do is go through all the parameters in this, find the ones that are the baud rate, data bits, all that stuff, and match them up to the box here. So let's see if we can get that done. Okay, let's get this machine powered on and homed out. Servos are off. Hit the servo button twice to get your servos on. And then on this machine, what you got to do is, if you're on the home limit switches, just jog it off. And then you just home it out with these right here. You just hit it, it'll start going up, you let go of it, it'll slowly go by itself until it hits the 0, and then you'll get a light right there. You do that with all 3 axes. And then if you have 4 or 5, you do it with all those axes. So there we go, nice and homed out. All right, I'm gonna get a tool, put in the spindle, and then warm it up. These are BT40s that this machine takes. All right, let's put the program in here, get the spindle running. M03, speed 500. Just get it warmed up a little bit. Hit that, it's in high gear. It should switch to low gear. There it goes. You see here we're at 500 RPMs. Nice and smooth too. Like I said, if you missed the Will It Run on this machine, go back in my previous video and check it out. Really awesome video. So now what I need to do is get into the parameter screen on this and figure out which one of these numbers matches up to the baud rate, data bits, and all that, so I can match these two up. And I have the manual right here, and it tells you how to set all this stuff up and what numbers mean what. So each of these values here, like 0 through 7, has a different function on this line. Okay, so I don't know if you guys can see this, but this is how you set all the parameters that I was talking about to match up to this DNC box right here. And this is how you find out what the machine is already set to. So this one, for instance, it says to select RS-232C interface port, select the port interface by setting number 6003. So if you want the first or second port, so on this one it looks like there's only 1. So normally they'd have 1, they'd have 2 back there. This one has 1, so I'm going to assume it's already set up correct. But you can see here, if you want to set the first one, it's going to be 60030 and 60034. And to change those settings, to make those settings, those parameters should have a 1. So if you look, 60030 has a 0, and 60034 also has a 0. So that's not the port that's selected. So for the second one, 6003D, it says slot 1 should be a 1 and slot 5 should be a 1. So if you look in here, slot 1 is 1 and 5 is 1. So I'm assuming this is set for this, which is great. So now we just go through the whole thing here and figure out what the data bits are, with the stop bits, and make everything match up to the DNC box here, or make the DNC box match up to this. So what I'm really interested in is the baud rate, like how fast this controller will import a program. 9600 is usually what I run, and that runs pretty good, but anything above that is great. So it says the baud rate right here, you can see it's 60026, and it shows you 3210, what these settings have to be this high. And you can see right there, it does have 9600. So this is going to be 60026, which we can type in. 6026, I'm sorry. 6026, you can type in, hit cursor down, it'll go right to it. So then if we want 9600, we want 0 to be 0, which is what it is. We want the 1 slot to be 1, which it is. And we want the 2 slot to be 0, which it is. And we want the 3 slot to be 1, which it is. So they've already had this set up to 9600 baud rate. So I assume the previous owners were drip feeding to this or importing programs at a baud rate of 9600. So then if you look at the stop bits on here, it's the same line, 60026, but it's going to be number 4 should be a 1 or 2. So if the line number 4 on 6026, I don't know why I keep saying an extra 0, but 6026, if line number 4 is a 1, it has 2 stop bits. If it's a 0, it has 1. So we're on that same line right there. And if you look at 4, that's a 1. So that means the stop bits are set to 2 bits on this machine. So on this box, you just plug it right into the wall. Like I said, it magnetizes to anything steel. And you get your RS-232 cord here, cable, and plug it right into here. And we got lucky because this is a male and this is a female. Sometimes they're the same, and you have to get a converter to convert them to be the same. And then to set this box, you just hold set, flip this up. I feel like I'm a salesman for this box. Maybe I should be. And then you go into communications, set. So then we know our baud rate. See, this is at 4800. Our baud rate on this machine is 9600. We set that. And then data bits, we know is 7. I just know that because I looked in there and saw what it was. Parity. Stop bits. Oh, I went back. Set. Stop bits is 2, which we set it to. So we know that's right. Go back, double check that. So this should all be correct. Then you go into there, boom. And I actually have a program saved in here for the other machine. So this is a little small program that I used on another machine just to see if I could import it. So I know it does work. It's a Yaznak Post. So these should be set up. Okay, so let's go in here and try to import this program and see if we have the parameters correct, which I never get on the first time. Sometimes it takes a long time. We're in MDI now. I can't remember if you have to be in memory or edit maybe. I think edit, but this brings up a program that's already in there. Parameter sets, there's a tool offsets, command, program, in, edit locks on. Let's see. It shows edit lock is on. Let's see. Okay, in, reset. So I need to delete this program that's in there. Let's see. Erase. No. Let's see. Let's enter the program number 00039. And then maybe if I hit erase, that will erase out of there. Yep. And then here's another one, 1002. So 01002, which that seems real familiar because everything that comes out of Fusion is like a 1001 or 1002 program number. So maybe they were already doing this. So let's see. Erase, not found. Okay. So it's saying that one's not found, but that's definitely a program. This is 00000. Erase. Oh, there it was. So erase that. Okay, so now I got to remember how to import. Let's see. So I know set this to send. So that's in the send mode, ready to go. So I think it's 01001. Then there's an EOB, and then input error. Let's see if it even tried. No, it didn't even try. Okay, so I figured it out. You have to be in edit mode. You have to type in the program name, which is 01001, and then under the memory data, you hit in, and boom. See, it came in? Bam, there's the whole program. So it just came from here over to here, which is awesome. So that means we have communication. So now for tape feed, what we do is put it in a tape mode, right? And then I think we do the same thing. We just have it loaded, ready to go. I don't even think you type in the program number. I think you just hit enter. Buffer alarm, ready, program error, G. So maybe you do have to type in the name of the program. Let's go to program. So we're in tape mode, 01001. And then in? No. I know you just hit this, but let's see. Yeah, so it actually brought that in again, but didn't end it. So I don't know if you just hit start now. Yeah, see, you hit cycle start. So it's gonna do a tool change and try to run that program through drip feed. So there's a buffer. Oh, see, I had to hit cycle start there. So I must have had it in high gear. So it is bringing this in as a drip feed file. See, because it's only at 4.2%, so we can drip feed to this machine. Let's see, alarm, program error G, reset that, program or parameters, position, program. So there is a way to get it to read across the screen. I don't know, just because there's not enough of a file there to do that, it's not showing it. But you can actually watch the machine do everything. And I don't want to do it because I don't have the offset set. So let's go back through here and see if we can cancel this and go back through and actually set up some tools that I bought. Set an offset real quick, make a little program, see if we can run this thing. What I'm going to do now is get some tools set up, get a vise on the table here. I've got a Kurt vise over here. I've actually got like probably 20 or 30 of these vices laying around here. These are all Cat 40s from the last machining center I had that I was using. But I'm going to get this set up on the table. And I used to have a bunch of BT40 tooling, but I got rid of it all with the last machining center that I had that took a BT40 tool holder. So I went online and purchased a bunch here. A couple of them. These are BT40 with ER32 collets. So what we're going to do is I'll just set one up, and then we're going to set up a vise with a square piece of stock and just kind of come down and reference the corner with the end mill that's in there and just try to roughly machine some stuff just to see if we can get this thing drip feeding. See if these T-nuts fit in there. These are the ones that were on the vise that I used from before. Sometimes different tables have different widths of T-slots, so they don't all fit with every table. Oh yeah, those fit in there. Awesome. Ugh. These vices are not light. So like I said, I'm not doing anything high precision right now, so I'm not going to worry about everything being set up perfect in here. I don't want any chips under there though. Let's see, maybe set that vise right there on this one. That there. All right, so of course one bolt will fit with the washer, one won't. So I got to find a little bit longer bolt here to go in this one. Actually, the washer just came off, so this might fit. Let's see. Boom. Okay, got it to fit. I said one fits with the washer, one fits without. Weird, same bolt. So what I usually use when I'm machining is a Heimer gauge right here, but this is a Cat 40, and I don't think that I have an ER32 collet big enough to take the shank of this. So I probably won't be able to use this right now to dial this in. Like I said, I'm just roughly doing this just to see if we can even machine with this thing. And then I'll go through and try to find a collet holder online or a tool holder like this that will hold my Heimer gauge for later. So right now we're just gonna kind of roughly get it lined up, bolt it in there, and see what we get. All right, let's get this tightened down. Like I said, it doesn't matter. I'm just gonna roughly eyeball it, square it up here. Looks pretty good. When I actually do machining that matters, I'll dial this all in and get everything lined up. Now let's break out a tool holder. What I want to do is just put a bigger end mill in here, maybe like 1/2 inch if I have one. 2 flute, and then we'll see if we can machine some aluminum. So these are pretty nice. They're like, you get like 5 of them for like 150 bucks on Amazon. I'll leave a link in the description below for these if you guys want to check these out. They're balanced to 20,000 RPMs, and that's pretty cheap, because you know, if you get like a Kennametal or something, these things are a couple $100 a piece, and for the work I do, these are totally fine. They hold great tolerance. So let me get this tool set up. So I have a little cart here that I've had set up for a long time. Kind of becomes a catch-all for everything, but when I'm really doing machining, I use this thing, do my tool lengths right here, measure everything. Then it has this little holder right here. That's how I kind of tighten stuff down and tighten the nuts down. Works out pretty good. So now what I want to do is find a tool that I'm going to use. We're going to do some aluminum. See if I got anything already loaded up that I can take out. And now, because I was doing steel with all this. Let's see what I got. I have a lot of stuff. I've got a lot of Cat 40 tool holders, man. That's why it almost sucks to switch over to a BT40 machine. See, there's a 2 flute. And that's a Cat 40. These are all Cat 40s right here. Sucks to switch over. So let me see if I can get this tool out of here and we can use this one. All right, I'll pop this one out. Put this back in. That looks like a pretty good end mill. We'll find out. Been in there for a while. So I know it's really important to blow these out, make sure there's no chips in there so that everything seats well. Then a common mistake that I made when I first started machining was I just kind of stuck that in there, stuck the tool in there and then twisted it down. I didn't know that these collets actually snap in to the nut. I had no idea. And I was getting everything messed up every time because everything was getting offset and this collet would kind of sit at an angle. So you got to make sure you do that first. You know, long-time machinists are probably watching this like, yeah, duh. But like I said, I didn't know that when I first started machining, and I was having massive problems. Like tools would start coming out of the tool holders and everything. So let's see, get that in there. So that one's in there. Okay, so now that that's in there, I need to figure out the tool lengths and the flute lengths and everything, and I need to generate that tool over here in Fusion 360, actually make a part, and we'll find some stock. Let's see what we got here. I know I got aluminum stock all over here. There's my 12-foot by 6-foot plasma table that I designed and built. I use that for a lot of stuff. Great machine. Check out all the steel stock that I got. Check out this aluminum plate that I got a long time ago. This thing is like 4 inches thick. It's the size of this whole pallet. I got that. I got all this steel, I think, for 150 bucks at a company that went out of business about 4 years ago. And there's other parts of it over here, different stock. So I got a bunch of aluminum stock here. It's all round bar. Here's some square stock for a project that I never used of aluminum. And here's some aluminum plates that came with all that stuff. Like I said, it was 100, 200 bucks, and I got all this stuff. Sheets and sheets of that. I actually used some of that aluminum to build that plasma table right there for the gantry. All this stuff, that big plate back there, all this stuff came from one place a couple years ago. I've had that around for a couple years. So if you see here, we do have some. There we go. This is a pretty big block right there. I hate to kind of mess that up. Here's a little one, smaller one. Let's try this. Let's get this in here. It's a nice chunk of aluminum. Like I said, we're not doing nothing really high tolerance today or anything, any tolerance at all, really. Just want to see if we can machine it with it and maybe get a form out of it. So I'm just going to design a real simple part. Measure this, maybe just do like, make a circle with maybe a hole in it or something. Let's see, we got, this is 2 inch by 2 inch. So I'll design a part with this real quick, and then we'll go in and we'll set up that tool and then set up some offsets in the machine if we can figure out how to do it, if I can remember how to do that. And then we'll see if we can machine. All right, I got this little part design here off of this square block. Just took me a couple minutes, real quick. So it's just that block, and we're gonna take off the outside, make a circle, and then put a circle pocket in it. So now I can go in here to the tool library. I'm gonna set up a whole nother tool. Let's see, new library. We'll call this Matsura, however you spell that. Add a new tool. It's gonna be a flat nose end mill. Then the cutter. Number of flutes, that's gonna be 2. And then let's do some measurements here and see what this tool actually is. I'm not sure what this is. So the shank on this tool is, it says 0.37. 0.376. So that's what I'm going to enter in here. 0.376. Shaft diameter, same 0.376. And then overall length, I'm going to say like 5 inches. And then length below holder. So this is what we got to figure out with this height gauge. So just set this on here. Go down here. Length below holder on this is 1.50 on a dot. We'll put that in 1.50. And then it's got a shoulder length, which is going to be like, I usually just 1.34 is the shoulder length on that. 1.34. And then the flute length, just going to put a little bit above it, 1.20. So now you can see here I have all those parameters set in there. And it asks us at high-speed steel. This is actually carbide. So we're going to go, you can type in your cutting data. So let's just keep this down at like 4,000. And the feet per tooth and inches per minute usually match up pretty good with Fusion compared to when I've done the math on them. And then we want to go down to, I think we can also set it up so that there's no coolant that comes on, because I don't have that on. So disable that. Boom. So that tool's set up. So now we got to make a program to go around the edges and a program to go down in there and then export it. So if you watched the other video where I had those Werner Swayze lathes and I tried the same thing, I was able to import a program, but the program wouldn't run barely at all, because one of the major hurdles with doing this type of thing is the post-processor. So the post-processor pretty much is a translation between what you're doing in Fusion 360 and the controller. So it basically tells your machine how to cut this part. and it's a translator. So their stock one sometimes works, very rarely. But lucky for me, on my video where I did the will it runs on these Matsuras, one of you guys reached out, and I really appreciate it, that has one of these machines and actually sent me a post processor. So I want to give a shout out to Gabe Gartner. Thanks, bro, for hooking this up, man. He sent me the post processor here, and it's for the Yaznak MX3 controller. So we're going to use that. And now when I go to export this, I should already have basically the translation software between Fusion 360 and this controller on this machine. So that saves a lot of headache, a lot of time. It's a lot of work to get these post processors. There's even whole companies designed around just building post processors for companies for the machines they're using and the software they're using. And they can be thousands and thousands of dollars to get those post processors made. So again, thanks, Gabe. So I'm just gonna go in here and make a really, really quick and simple program. Like I said, we're not doing anything high tolerance. We're just trying to see if we can actually make a part. So we're gonna go to choose that end mill that we made there, boom. And this is a adaptive tool path. So let's just see what we get first. Boom. And you can see it does everything, but look at that monster step over. I'd probably blow that end mill apart. So then I go from here and just go to optimal load, which means how deep of a cut you're taking. So we're gonna change that. Let's go to 1,000 and see what that gives us. And then boom, look how fine that is. But that's, so I don't know, that's really, really, really fine right there. That's probably too fine of a step over. So we're probably gonna go to like 10,000 step over, and that should be good for this cutter. So this right here is tool 1. Take that out, put the tool that we made in. So this is a tool that we set up, and that's going to be tool 1. So now some tables don't go down far enough where this would touch to this on the table. This is exactly 2 inches, and some will. So if it doesn't, what I'll do is put a little block on there, and I like it to be lower than the vise, because then I know every offset that I make is a positive number. Makes it easier for me to remember. So let's see how far down this table goes. So I got lucky, and the spindle actually goes down far enough to reach here. And you can see, I don't know if you guys can see, but that's dead nuts on 0. And if you come back over here, you can see the machine numbers. These are all zeroed out. I made sure to home it back out. And then we have minus 18.8170. So that's going to be tool 1 position. Take a picture of that. So I got to figure out how to set tools in this. Settings, no, it's going to be in offsets. There we go. So tool 1, see, the tool 1 they had was already at 18.9112, so it was a smaller tool. Let's cursor down to that. And see, it says positive universal, and I'm not sure if this is the offset that I put in there, but I don't think so, because these are all 18s and bigger numbers, so they were using smaller tools themselves, I think. Shorter tools, should say. So let's just go to, let's type it in, minus 18.8170. And then right. Yep, so that changed it. But see, it changed it too far to 37. Which isn't right. That's not correct. So I can't remember how to offset tools on this thing. And there's, like I said, under, when you go to position, there's 4 different ones. The universal, the external, the incremental, which all these are the same, but the machine is at negative 18.8170. So I don't know if, when I'm in this offset, there's like a calculate. I know there's a measure. See this measurement right here? What if I just hit measurement? Tool 1. Right. Okay, so I did tool 1 and right, and it made that 0. So I don't know if that's correct. I doubt that's correct. I should read the manual on how to do that, because I can't remember how to do that. I know that's not correct, because all these tools aren't, that they have programmed, aren't going to be like negative 18, negative 21, and then mine's going to be 0. Let me read the manual real quick and figure out how to do that. Okay, so I read through the entire manual, and it actually says to find out how to do a tool change and use these measurements, refer to the Yaznak manual. So I read through that whole manual. There's nothing in there about that. So I'm gonna go with my gut and what I think I know, which is where this is moved from machine 0. So this is 18.8171, and I'm gonna go to offsets, and I'm gonna put that in there. So I'm just gonna type that in there, negative 18.8170, and write that in there. So that's what our offset from 0 is. So then when we go to next, you can see here's our G54 value. So this Z, it looks like you don't type in the actual position. It looks like you type in what the offset is. So like I said, since this is a negative, it's always gonna be a positive number because I'm going so far down. To get to the workpiece is always gonna be up here, so it's gonna be a positive number. So I assume if I take that same tool, set this in the vise, touch off on the top of this, whatever the difference is between the two numbers in a positive orientation is what that number should be. So that's what my gut tells me. That's what I've done on other machines, unless this machine's different. So let's try that. All right, let's get some parallels in here. A little bit too big. Those right there should give us enough. All right, got that in there pretty good. Give it a love tap. So now, since I'm not using my Heimer gauge, I'm just gonna use a piece of paper, kind of roughly touch this end mill to that, and see what number we get. So right there, it's hard to get the paper out. I'm gonna say that's the 0 point. Let's see if I can remember how to do this correctly. So we'll go to offsets, go back to that tool. So that tool is set right there, which we know is lower and going to be a higher number. So we'll go 18.8170 minus where we're at now. So we subtract that number from that. That's going to be 14.7214. So that gives us a positive 4.603. So I think that should be our offset number. Now I got to figure out how to change these. You just type it in, Z, yeah, Z 4.6030, and then input, maybe that will get that in there right. Oh yeah, so see that changed that number? So now our G54 height should be set 4 inches from down here to the top of this stock, if I did that correctly. So now let's go up off the stock, and then now you would take the Heimer gauge and kind of bump the sides and find the corner that you're using. Let's see, what did we set on this program here? Okay, so we set the upper left-hand corner. So I'm going to jog it over to here roughly and just make that the corner and get those coordinates. So let's see here. Go up till we're about halfway. Like I said, this is going to be a really, really rough estimate. Let's bring it down a little. I'd say a little more to get it to half. Yeah, about right there. So that's going to be our Y. Let's go to X. See if we can roughly get that dialed in. So that's just eyeballed, and so that's going to give us position. This should give us our rough positions for the offset in these two, maybe. So I don't know how that's going to work, because these look like they're not that big of numbers. But they may have had this sitting off to the side or something. I'm not sure. And should these be the numbers, is that why those universal numbers are there? To let you know what to put here. I'm not really sure how that's gonna work. I think I'm gonna go with my gut again and just kind of put those numbers in there. See if that works. If not, I can use the universal numbers. Okay, so I think I have that set. Let's change it from tool 1 to a different tool so it'll actually do a tool change and we'll know that the program's running, just in case it doesn't come across the screen. Let's go M06, tool 05, write that. And I also want to make sure that tool holder grabs correctly when it tries to come out of there. Okay, awesome. All right, so let's see. What is the feed rate on this machine? So inches per minute, I guess that would be that one for the rapids. This must be for how fast the machine moves the whole program. Let's move that down. I think this is the spindle. We'll just keep our finger on the stop button and hope for the best here. So there's tape, feed, and I guess 02001. And then input, or I can't remember. With tape feed, I wonder if you just hit the start button. Usually you just hit the start button. Let's see if I just delete that, reset that, or if I just hit the start button. Buffer alarm, error, overrun. See, so that means, and let's see, did it start coming in? Nah, it didn't start coming in. Well, it does look like, yeah, it's at 0%, so it did start coming in. So now it's ready. So what I think is my offsets are wrong. So let's see, offsets. Let me change these to the universal numbers that I had wrote down and see if that works. Okay, so I changed my offsets here to match the universal numbers that were set where it's at that upper right hand corner. Let's see now. So here's program. Program's ready to go. Monstrous G-code. I don't know if you even got to type in the program. I think you just hit cycle start. Yeah, there it goes. Alrighty. There it goes. It's going down nice and slow. There, I can bump it down to 1%. Kind of manually going to 1% to 25% here. Let's get it down here. Got it to 1%, so I can hit stop, and that does stop it. And you can see it is feeding in. It's at 0%. This code's so long it's at 0%. But I wonder how you see what's coming in. There is a way to see that. Nope, nothing's changing there. Program. I guess for now we just can't see it. But let's see, we got some machining going here. It's going down. Is it going down to the right offset is what I'm wondering. Nah, it looks like it's going down too far. See how far down it is? It doesn't go down that far on the part. So, let me stop that, reset that. Let's go to MDI, go to M00, write that. So that stopped that. Let me home the Z back out. Go back up to 100. There we go. So I do think on this machine, when you're doing your offsets, your G54 offsets, it is the number that you see right here, which is different. It makes it easier. So let me change that number to the number that I took a picture of and see if that works. Okay, so I think I may have it figured out with the offsets. So I had to reset everything, get everything back to 0. When I did that, all the positions were the same at that time. So when I did that and did my offsets, it actually worked out where it was -18 or whatever, went to those corners and did that. So my Z came down, took a little bitty cut right there, but it was a little bit too shallow by, I don't know, almost ½ an inch. So I went and redid the Z, kind of measured it out. This thing was moving, man. Even though I turned this down, it was moving. So let's go to program. We can actually go to position here, go back to tape. It's really easy to tape feed this machine. The program's ready to go. So we just hit that start button and starts moving. Oh, got an alarm. Overrun. So it gave me the overrun, which doesn't make sense because I only changed the offset right here by maybe 3/4 of an inch. So I don't know why I'm getting that error. Let's try it again. Go to MDI, program M00. Stop that. It did start feeding in. Let's go back. Let me reset this whole thing here. So that's ready to go. Let's see. Let's go to tape feed. Let's try it one more time. Oh, there it goes. So let's see how far it goes down. I'm just kind of hand on the stop button, go button. Oh. Oh. Yeah, let's see. Let's get it down to 1 there. That's going mega fast. So that looks like about the right depth if that's where it's going to stop. Yep. But it looks like it's going to hit that material hard. I don't know if I could slow down the feed rate on here. Inch per minute. Yeah, I guess it looks like it's about in the right position. It's just a matter of figuring out the Z offset, but let me set this up on the tripod and actually run it, hit the button and see if we don't snap this end mill or what happens. All right, so let's hit run and see what happens. Might snap an end mill, but it is what it is. It's actually machining beautifully. You can tell our offset's off because it's not touching on one side. But that's okay. That's to be expected when you're just eyeballing your X, Y, and Z coordinates. But it looks like it's machining pretty nice there. Looks like our X and Y is off pretty good there, but quite a bit actually. But now it's starting to touch. And it's actually machining beautifully, man, beautifully. So stop it here. As you can see, the code, I stopped it. The code's just drip feeding in. This is a modern program with a lot of a helical, what you call it's in there. And this is a monstrous code. It's only 3% done. The code is so big. So far, we are machining a modern Fusion 360 program. And it's running beautifully so far. So there's no jittery movement. It's taking the code nice and smooth. It's running the code nice. This is a real conservative cut of 10 thou depth of cut. But you can see the cut on there. It's running nice. It's nice and smooth. Okay, so there is something weird with this post processor and this particular machine. It was running beautiful, and then all of a sudden it came up like in a program. I think it comes up and does different parts of the profile and drops back down. This came all the way up and hit a limit, so it over traveled and then it stopped. So I think let me try to. What I did was redid the program, turn the smoothing on to make the code just a little bit shorter. Change the step over rate, and let's see if maybe we can get that corrected. I don't know why it did that. It's got to be something with the post processor. So if this ends up not working, we'll try the stock Yaznak post processor from Fusion, see if that works. But I'm pretty sure this should work. And Gabe, the guy that sent me this, had told me it was for something with like a single tool changer or something like that, or a single tool. So maybe that was part of the problem in there. So let's run this through again and see what we get. Okay, so I got it back to where we left off. I did get an overrun alarm with the RS-232. So I think 9600 baud rate may be a little much for this machine. I dropped the feed rate down to 60% because I'm taking a bigger depth of cut. But as you can see it finished that pass. Now it's going back up again, and then it's going to alarm out. There's no reason why it should even be going up. So that has to be a post-processor issue. because this, if you look at the program here, it shouldn't be raising. If it raises up, it just goes up here and goes over and drops down in the program. So this is about where we're at now. And actually the tool's not even lifting at all. Okay, so see there, it lifts and it does those little cuts on there. I don't even think we're to that part yet. So this is definitely something to do with the post processor. And you see we're getting to like an N30 there. So let's post process this out again. And let's use the stock Yasnac post processor from Fusion. So now I got it all back reset, and I actually exported this with the stock Yasnac post processor from Fusion, and it's ready to go. Let's run it, get it back to that same point, see if we have that same problem with it wanting to go back to home. If we do, it might not be the post processor, it might be something in Fusion, one of these parameters that we have set in here. But let's check it out and see what we get. Okay, so the stock Yasnac post process doesn't want to work at all. So I'm getting an overrun error automatically, and I'm getting a program error of G alarm 20. So it's also reading something that it shouldn't be reading. So the one that Gabe sent me actually is the better one, and that one was working to get to a certain point, and then we have a problem where it's coming up. So it's definitely a post processor issue. Let me mess with it a little bit more, see what I can figure out. Okay, so I changed a couple of settings in the post processor in Fusion. There was a couple settings here that had like safe retracts. I put clearance height. Also for 5-digit program number was selected, so it only needs a 4-digit. I took that out. And allow helical moves is in there. I took the pitch for tapping out. So I did that, and it started running immediately. It started dropping down real quick. So let's see how far it gets. I had to turn the feed rate down there. Okay, so we're back down there. Looks like it's going right to the same height. There we go. And I got the feed rate turned down to 50%, so we don't get that buffer alarm error. Like I said, I probably need to change the baud rate back down to 4600, which is plenty to run the program at 100%. But I think this will keep us from getting that alarm by running it a little slower. So let me get back to the place it was when it went straight up, and I'll bring you back. Okay, so we're just about back to where we were in the program before. It's actually taking a little bit off. Let's see if the Z-axis still wants to just go back up to home and over travel. It may have been because there was no option in the post processor that Gabe sent me. Yep, so there we go, we're rolling. We are machining. And I got it turned down a little bit, the feed rate. So the problem was in the post processor I got for Gabe, it was good, it worked, but the problem was there was no option to select your retract distance. So the retract distance on the stock Yasnac post processor, I reset to safe retract distance, whatever I set that to in Fusion, instead of G28. So the G28 was telling it to go too high and retract too far. So we figured it out. We are machining a modern program in Fusion 360. Let's check this out. Let's see if we can go a little bit faster without getting that buffer. I got it at 40. Let's go 70. I'm also taking a lot deeper of a cut, so. But now it's made it further in the code, and oh yeah, it is going over. So let's turn up our movements here. That's pretty fast. So I had to turn the rapids back up. So these are the rapids at 25%. At 100%, it would be super fast. So there we go. It ended the program by itself. Like I said, I turned the rapids back up. That was 25% on the rapids. If I'd have had it at 100, that thing would have been moving. And I got it up to 70%. I wasn't having no problems with the baud rate. So I think 4600 would still be better on the baud rate. But let's check it out. Let's go back into handle. All right, it looks pretty good. Like I said, there's no finishing pass on it or anything. That's just rough, and it's left stock on there. But that is modern machining. Maybe I'll go back into here and make a finishing pass. But what I'd really like to do is drop down into that hole there. Maybe let me make a program for that. We'll export that and see what we get. All right, so I created a quick program here. You can see it drops down in there, does a little helical move, and knocks out that center of that pocket. Let's see what happens. So we got it here, tape feed, got it ready to send. Let's see if our heights are right. Oh yeah. Okay, so we're just about to touch. See what happens. There we go. That is machining that pocket. So that's it. That's that little pocket machine in there. I don't know how well you guys can see it, but it looks good. Nice smooth finish. So I really need to figure out how the offsets work. I think I have the offsets off a little bit on this. I'm positive that I do, because when it came down, it didn't go down as far as the pocket in Fusion. So I definitely have that Z-axis offset off. But we machined a lot of good chips, man. Check it out. Those are really nice chips. And this is a really nice part. Look how smooth the inside of that is. Nice and smooth. Even the bottom is smooth. So a little bit more tweaking with the offsets, figuring that out. And just kind of dialing in the program in Fusion. And maybe just a little couple things on a post processor need tweaked, maybe not. And this machine will run modern code all day long. Like I said, I think if we drop the baud rate down to 4600 as opposed to 9600, it will probably do a lot better. But I got no jerkiness or anything out of the machine, so I just dropped it down to, I actually had it at 70% there at the end, feed rate, and it was running fine. So I think that was a huge success, running modern code on a machine I paid $350 for. Again, if you didn't see the video on the will it run on this machine and that Matsura right there, go back and check them out. Great video, man, on these two machines. I got a killer deal on these machines. Didn't know if they ran coming in the door, and obviously they do. Also, if you haven't caught part one of my 8-foot DIY hydraulic press brake build, go check that out. I'm getting ready to finish this up hopefully this week. That second video will be out soon. It's a little sneak peek right here of the progress. And I've got some other things in the works too. I have a plastic injection molding machine back there that I picked up. That's a 2000 with a CNC controller. Got a gigantic vibratory tumbler in right here. I paid $200 for this vibratory tumbler right here because that company was going out of business. And I also got that for around $1,000. Great deals on some of these machines here, hence why I'm a machine dealer. Let me know if you guys want to see a will it run on this vibratory tumbler. This thing is a monster. Bought this sight on scene with the injection mold machine, company going out of business. Got a killer deal. I don't know if it runs. Here's the control panel right here, just kind of laid haphazardly. Has this drive in it, which I don't know if it works. Variable frequency drive. We'll see. Those get damaged pretty easy, and as you can tell by the state of that, they kind of didn't care when they loaded it up. And if you guys are new to the channel, go back and check out some of my previous videos, man. They're pretty awesome. I appreciate all the support from everybody that I've got on all those videos. And I also appreciate everyone that's went and bought one of these caps to support the channel. Really helps me out, man. Keeps me motivated to make these videos while I'm working. You know, it's really hard to sit and make these videos while you work doing this type of work, but I try to find time to squeeze it in and do it, because I know a lot of people want to see this stuff. So if you're interested in purchasing one of these hats, go to my website, www.prestigemanufacturing.net. Go to the merch section, pick you up one of these hats. I got a $5 flat shipping fee. Makes it pretty affordable. Thanks again. See you guys on the next one.